And so, good day, everybody. My name is Stephen Klontz. I'm recording a up-to-date walkthrough on how to contribute to the PyBase database of topological counterexamples for September 2025, late September 2025, almost October. Um, and so, let's go ahead and just dive on in. So I'm going to give the briefest of introductions to what the heck the PyBase is. So the PyBase is a community database of topological counterexamples, which means that we track three things. We track topological spaces, which are all different examples from the literature of examples of topological spaces. Spaces can have certain properties. And then to connect the spaces and the properties, we have two things. First of all, every space can be annotated with the types of properties that it has. So for the deleted integer topology on the reals, remove the integers. We have several properties. Some of them are true, some of them are false. Some of them have been contributed by humans, not that many, of course, because we have a lot of deduction. So anything with a robot is what we've deduced about these properties. And in this particular, I love it. So in this particular example, we know everything we could possibly prove in ZFC. Obviously, we don't know without the continuum hypothesis or its negation whether the cardinality of this space is Aleph 1 or not. But we've done a pretty good job of fully characterizing up to the properties that the PyBase knows about, the properties of the deleted integer topology. And of course, how do we actually deduce these things automatically? Well, anything that's automatically deduced is being deduced from our theorems. And so, for example, the deleted integer topology, we've asserted that it has cardinality equal to the reals, it's second countable, and it has a topology which is a partition of the space. And so that means that, oh, sorry, that it's not yeah, it is a partition of the space, right? And then from that, it's not T1 because if you were T1, you'd be T0. And if you were T0 and Alexandrov and second countable, you'd be countable. But we're not Alexandrov. Oh, sorry, we are Alexandrov. Okay, hold on. How does this work again? Uh, we are not T1 because then it'd be T0. All right, but we are Alexandrov. We are second countable. If we were T0 as well, we'd be countable, but we're not countable because we have cardinality equal to the reals. There it goes. So all of these different theorems are different results, and we have, of course, the human proof of that result. In this case, it was considered to be so basic enough that we didn't have to cite the literature for this. But in general, we try to, if it's not a, in this case, of course, the cardinality of the reals, that is by definition. We don't need to cite anything for that. Probably don't have a lot of examples of citations because it's such a simple space. Um, but if we go into some of the more intricate examples of topological spaces, maybe we'll do one of the Plancks. Tikhonov Planck. It is not completely normal. I'm going to guess that, yeah, it contains a subspace which is not normal. And then why is that space not normal? Well, we can look that up. That was actually deduced automatically from the fact that it was Cauchy paracompact and Cauchy metacompact. And that was established in a math stack exchange post. So, um, PyBase is a database of formally modeling informal knowledge of mathematics. And so we try to keep to the literature as closely as possible. We try to do as little peer review of the mathematics as possible by factoring it out into if it's either very simple results, we'll give a short proof in our own database, but often we try to encourage discussions if it's worth a discussion, having that done on Math Stack Exchange or Math Overflow, if not something that we could just pull directly from the literature. Um, so how does one contribute to the PyBase? Well, if we go over here to the contribute tab, we have a place where you can always say hello. I don't think anyone's actually said hello except for myself. But more importantly, you get a link to the PyBase data repository, which is where all this stuff comes from. And so there are two aspects of the PyBase. There's the data repository and there's the web repository. If you're interested in the software, which is not what we're talking about today, but the software that powers the PyBase is over here at pybase/web. But if you're just interested in contributing mathematics to the PyBase, that's pybase/data on GitHub. So in order to contribute to the PyBase, if you're not logged in, you can still see all the data because it's an open source project, but you'll need to sign up for GitHub. It's a free account. You don't need to pay for anything. So you can set up your free account here at github.com. And so once you have your account, once you come back to the page, you should have the ability to fork the PyBase data repository. And I've got one person participating live with me today, so let me take a break for a moment to make sure. Do you have your uh, account, and are you able to click this fork button?
Yes, I do have my account.
Okay.
Give me just a moment.
Yeah, and I'll put this link in chat for you as well, so you can get to it if
Oh
I can
yeah, that would
find
be
it.
great.
Yeah, perfect. So I'll put that link in chat. This is at, again, all this is available at topology.pybase.org through the contribute tab. And then we're at the data repository. And what I'm going to do right now, I can actually make branches on the repository directly, but your first time that you contribute to the Pybase, you won't have that permission. So you'll have to do what 50 other people have done, which is create a fork of the repository, which I'll go ahead and do now. So what this does, and if anyone, you don't have to know a whole lot of Git and GitHub to participate in the PyBase. However, I did write this handbook called GitHub for Mathematicians at g4m.codeformath.org, which is a nice little reference for how to use GitHub, especially the web features of GitHub to interact with any Git repository for a mathematics project. So the idea here is that when you fork the repository, this is all this open source data, which I'll show you what the data looks like. These basically just a bunch of text files at the end of the day. Um, and you are going to create a copy of not just all those text files, but the entire history of the project, at least the main branch of the project, if you copy the main branch only, which is probably fine. I would go ahead and rename this because Stephen Client slash data could mean anything. So I'll go ahead and call it Pybase data for my repository name and go ahead and create my fork. And so that's going through and grabbing all those text files. And now we're going to have a copy of the Pybase data repository at Stephen Clients or whatever your username slash whatever you called it. I called it Pybase data. And so the way that I would recommend to contribute to the Pybase is just to press the period key on your keyboard. If you do that, that's equivalent to changing the .com to .dev in the URL. So you can either change the URL like that, or you just press the period key on your keyboard and it'll do it for you. And what that'll automatically do is it'll spin up VS Code, which is a text editor, um, plus a lot more. It's a developer environment. Um, but this will spin it up in your web browser, and it gives you access to all the files in a editable format, as well as it gives you access to the Pybase extension for VS Code, which is going to automatically uh, fill out some stuff that we'll take a look at here in a moment. So it doesn't take too long to boot this up. This is all just running in your web browser right here. You can close that out. And a couple of things. First of all, if I click over here, I do see that it has in my extensions given me some markdown previews. It's given me so these are a couple of things actually from my other projects that I had installed, but the one everyone should have installed automatically. And if not, you can search for Pybase and install it as the Pybase extension. And what that allows me to do is I can go into a property one, and it's not just telling me that, or even more interestingly, let's go to a theorem one. So theorem one says that property 16, if that's true, then property 19 is true. But you can see here in gray, and if I hover over it, it's going to cross-reference and cross-link the other properties. And that's going to allow me to kind of navigate through the Pybase through the editing interface. And that's way more convenient than trying to, oh, I have to look up property 16. That would be a pain to have to do that, but this allows us to get there directly. If you have a reference, you can click the reference, open it up in a new tab. Here's the counterexamples and topology reference. Here's the Wikipedia page on compact spaces. And so what I think I will do here is first of all pause for questions or any issues. Using github.dev, were you able to get this interface
So
with
far,
the
so good.
extension? Good. All right. So now, what kinds of contributions could I make? The easiest contribution one could probably make would be to contribute a new trait to the database. So what would be a new trait for the database? Well, let me go back to, let's see, go back here. There's actually a questions tab at the top of the Pybase. Once I get that loads up for me, load that. There we go. And so I'm just going to kind of roll through here until I get something that seems a little tractable. Is LF2 size LF2 cardinality C, so it does not know about any of these things. This is stone check compactification of the integers is not homogeneous because we have some isolated points and some non-isolated points. So I know the answer to this one. So this would be a great example of how I could contribute this to the Pybase. So let's go ahead and see what would be involved and click through here. So we don't know if space 108 has, or actually, well, Pybase doesn't know, but I know that space 108 does not have the property P86. So how would I contribute that to the Pybase? All right. So I'm going to go back over here and I'm going to look up the space 108 and I'll open its README file to confirm that. And yes, I am in fact talking about the stone check compactification of the integers. Space 108 is also known as beta N, beta Z, beta omega, lots of different aliases to help with the search for finding this in the search bar. We have references to Wikipedia and counterexamples in topology. This is counterexample 111 from counterexamples in topology. Lots of different ways you could define the Stochastic compactification of a space. Here we have the classic ultrafilter characterization. And I want to tell the Pybase that it is not homogeneous. So I can go in here to the properties, and I'll just grab any one of these property files, copy paste. I'm going to rename it to be property 86. And you've got to like have the full-fledged, all the zeros. If we ever hit a million of anything, we'll have a good problem to solve. So we have up to space for up to a million different things here. So this is space 108, the stone check compactification of the integers. The property I need to update to be property 86 because it is homogeneous. You can see it updated the thing. And I know that this is false. And so I don't really have a reference for this. I think this is a pretty straightforward contribution. And I'm going to say it's not homogeneous. Um, the space is not, and I'm going to just say P86 and single brackets. That gives me the link to homogeneous in the write-up. It is not homogeneous because points of the natural numbers are isolated, but points in the remainder are not isolated. All right. I should probably check. I should go back to the definition. Oh, we're using beta omega, so I should probably, for the style match that we're going to do, points of omega are isolated, but points of beta omega, remove omega, are not isolated. And I think that does line up well with the definition. We identify N with the principal ultrafilter containing N. The topology on beta omega is generated by all sets of the form And so, from this definition here, for the sake of this tutorial, I'm not going to think about it live, but I should probably think about this. Is obvious to me as someone who's studied this space enough. Of course, the principal ultrafilters are going to be isolated. The non-principal ultrafilters, the free ultrafilters, will not be isolated. But it's probably worth deciding whether that needs a reference or whether we can make this clearer from the definition why that's the case, or whether, I mean, honestly, I could probably just go over here to Math Stack Exchange and look up StoneCheck isolated. Here we go. StoneCheck compactification isolated points. All right. This is not immediately lining up with the definition from ultrafilters. Depends on your definition. Yeah. So in any case, I'm not going to actually think about this now, but one could probably find a reference from the Math Stack Exchange. So almost certainly someone has proven from the ultrafilter definition that principal ultrafilters are isolated and free ultrafilters would not be isolated. If I did that, if let's pretend that was a good reference, I could add the reference, would be at list. And like many things, you can learn by just copy pasting metadata from other files, how to write the metadata. There actually was just recently a very good contribution to the wiki, which is another reference that you could look up if you go to contribute. And on GitHub, if you go to our wiki on the data repository, so go to the data repository, go to the wiki, and the format of database entries that has a good overview of all the different options you have for different types of references, how to set up a property, a theorem, a space, a trait is what I'm doing right now. And you can see how this looks here. So I'll go ahead and add math SE. You can probably find a better reference later. I'll grab that ID from the URL. And the name is StoneCheck Compactification, isolated points. And I can say C, for example, I use double braces, math SE, and grab that ID and paste it in. And that will add the reference to the Math Stack Exchange post to my contribution. All right, if I do like the preview here in VS Code, it doesn't do a great job. The plugin does not hydrate the preview with all the good information and cross references. Maybe it should someday, but it would help you like at least see if that your math notation is operating correctly. Um, okay. Again, I should probably pause to make sure that what I said so far made sense.
No, so far really good. Especially I enjoy that you post related it to Wiki and how it talks about references and stuff like that. That make it really clear.
Yeah, this is like I said, just the other day somebody started contributing this, and this is again, this is a community project. So apparently 2 weeks ago, PZJP started working on this. I think they shared it about 3 days ago. Patrick's one of our major contributors. He made a few additions, and I just got around looking at it just before this workshop, and I made a couple of contributions ourselves. So the wiki is a wiki. Anyone can update it and help make this a better reference for the um, community. The PyBase data itself is not a wiki. We have some level of peer review, and that's what I'm talking about right now is how do I contribute this? Well, one thing here in the VS Code, since I've made some changes to the database, we see this little thing right here that says I made a change, and it's tempting to push a big green button, but I should not do this because I do not want to actually change the main branch. If I go back over here to this, the only thing that you really need to know about GitHub is going to be summarized by this picture in the very first section of GitHub for Mathematicians, and it's this picture right here is the idea that the main branch is the official history. That's the top of this. Every circle here represents a commit. That's a change to the files of the repository that have been committed as part of the official history of the PyBase data. Now, what I want to do, because I don't have permissions to just change the main branch willy-nilly, well, I do, but in general, people don't, and I shouldn't abuse that power. I should branch off and make my change there. So I'm going to do that. To do that, I need to, before I commit and push this green button, I need to go down here to where it says the main with a little asterisk, which says I'm trying to change the main branch. I don't want to do that. I want to create a new branch. And so what I usually, this is my personal preference. You can pick any string that you want with certain characters, stick to alphanumeric stuff mostly. But if I do, I like to add my username. I like to add the current date. And then I could, that way, if I reuse the string, I don't get a conflict. It looks like I'm doing beta omega, not homogeneous. So something that kind of like briefly describes the purpose of my contribution. I'll create that new branch. I'll switch to the branch. And now I'm going to be actually branched off. I'm working now over here on my side branch where I can do whatever I want. All right, this is not going to mess up my copy of the main branch's history, and this is going to make it so I can make a very clean contribution to the main branch. So now I'm over here on B omega, not homogen. I'm going to go here to the source control. I'm going to commit and push to that feature, that side branch, the one that I own on my own fork of the repository, Stephen Client slash Pybase data. Add S108 is not P86. Maybe you probably should actually say B omega is not P86 homogeneous. So give a little descriptive commit message there, commit and push the green button. And what that's going to do is if I change the .dev back to .com in my URL, that's going to send me back to the my fork of the Pybase. And it's smart enough to know GitHub knows that, hey, you've pushed a new branch. Recent push is 16 seconds ago. And this big old green button's telling me to do the thing I should do, which is compare and pull request. I'm going to preface as a demo contribution. I'm going to actually make the contribution. I might even fix it up and make it a legit contribution later. But for now, I'm going to make this a demo. And so the contributors, the humans that are actually looking at this know I'm not ready to submit this. That and I'm also going to make it a draft pull request. So they know I'm not actually ready to submit this yet. But I'm going to make this demo contribution and I'm going to say, I noticed that, maybe I'll just put this link in here, is unknown to Pybase. Its contribution answers the question in the negative. Something that describes what happens. I highly recommend to leave this checked, allow edits by maintainers. That way, if they need to make a slight tweak, they don't have to wait on you to accept that suggestion. They can just tweak it themselves before they merge it in. And again, if I was doing this for real, I would maybe even change this to a create pull request and actually push there. But again, I want to actually clean this up when I'm not doing a demo, even though I think I really will contribute this and make it a draft pull request. The draft pull request says that it is not ready to be reviewed or contributed. All right. And again, once I'm here, that notice that this was actually made a contribution to the original Pybase data repository, the official repository. I'm making it to the main branch of that repository from my side branch that's on my fork of the repository. So everything's lined up the way it should be. You can see that the files changed. All I did was add one new space property pair called a trait. And I've made a contribution that says the space is not. Again, unfortunately, you can't see what all this stuff stands for anymore, but we remember that it's not 86, it's not homogeneous because points of omega are isolated, but points in the remainder are not isolated. Now, one thing that happens when you make a contribution from a fork, which everyone has to do their first time, is that it does not automatically process it or do any sorts of checks. So now I'm going to take off my contributor hat and I'm going to show you what happens as a maintainer if I was to go through and review this. So I'm going to go ahead and assign myself as a reviewer for, oh, I can't do that because I actually made the contribution. All right. I can still show what it would look like if I was the reviewer though. Um, any questions before I show what the review process looks like?
No, all pretty good.
All right. And so now I'm going to do a review. So in order to do a review, what I would first do, because this is a new contribution from a new user who has made a fork of the repository, is I'm going to really quick do some magic, very similar to the magic you just saw, but I'm going to actually copy this contribution to a branch that lives on the actual Pi-base official repository. And so you don't have to know the details of what I'm doing right here, other than I'm basically just going to rename this branch to I usually name it to match the pull request. Pull requests 1478. So again, once this all loads, it lets me type PR 1478. Oops, PR 1478. All right. And so that's all I have to do there because now if I refresh, now that I've copied it to the official repository, you see this little dot here, that's doing some automated compilation and pushing that's going to actually go through, crunch the new text file that was added to the repository, and actually build something that the Pi-base website can use. All right. So what should happen? I'm going to cross my fingers that it works, and it may not work. Is that once the change has been added to the official repository and this compilation push process is done, it should be available through the advanced tab. It should be that branch I called PR 1478. Hey, today it's going to work. Okay. I don't know why it's been hit or miss. Sometimes it's been broken, but today it's being nice to me because it knew I was doing a demo. So thank you, Internet.
That's great.
Yeah, I know, right? So what this is going to do is it's actually going to show me that contribution on the live website using this pull request data. I go to Spaces, I go to Stone Check, and I go to the human to find this homogeneous. It is not homogeneous. I can see that it's not homogeneous because the points of omega are isolated. The points in the remainder are not isolated. See, this is a terrible reference that I'll have to improve later before I really contribute this. But if I was happy with that, it would just go ahead and get contributed. It would probably just be, again, this if this was ready for review, then I can't even merge it unless I cheat, use my admin powers. What should happen is actually it gets reviewed. So someone's going to come in here and go review changes, approve. I can't do it because I can't approve my own thing, but another contributor could. Or they'll actually come over here and go, maybe select this stuff. Maybe actually, I don't need that dotted line in there. Cancel. Just select these three lines and make a note. This is not a high quality reference. This is the real feedback I have from myself. Perhaps you can find a textbook that establishes this fact, or a better Math Stack Exchange post or something else. Um, and so then, actually, I found one. So I'm still pretending I'm the reviewer, and maybe this suggestion could be made here. And again, I don't have a, so maybe there we go. Um, I'm gonna get a reference to. I'm assuming counterexamples in topology make establishes this fact. So I'm gonna pretend I looked it up in the book and that it did. And so maybe I'll just search for counterexamples in the repository. We'll see where else it's been referenced in just a moment. Here we go. Oops. I'm just going to copy this reference here. And so now I've actually, through the comments, made a suggestion that the contributor could replace this low quality Math Stack Exchange post with a reference to a canonical textbook of topology. This could actually be committed directly through this conversation, and that would actually dismiss the comment. No, see, now I've got to update this though. So probably I should also update this to say reference the DOI item 3 space 42. I don't know what this actually is. So this will not actually get merged in, but that's the kind of thing that would happen through a review process. Um, that's the basic idea. If I were to have an approval from another reviewer, I need to actually mark this as yeah, let me remark this as a draft. If you ever make it ready for review and then you realize you really should have it a draft like I did, it's kind of hard to find the button. It's not down here where you said ready for review. It's up here hiding under reviewers. Convert to draft. There we go. All right. And basically, if this were to be squashed and merged, it would appear in the main branch of the repository. It would appear uh, back at get-pybase/data. It would appear right here to this as the most recent commit. After 5 hours ago, we'll have another commit right here. And then a few moments later, that green check mark will appear for that commit. That will make it appear at pybase.org without having to change to a side branch. Um, and that's the basic workflow for making a pretty simple contribution. So, do we have any questions there?
The only question that I have is that you mentioned in the beginning that this was going to be recorded and put on a YouTube channel. Where is that YouTube channel to like find like other potential
Uh,
things?
Good question. So, we don't have a lot on our GitHub. I think it's just my personal GitHub channel that I posted this to. I thought I had already done this tutorial. Coming soon. Okay, so maybe it's been a beat since I've done one of these things, and I thought I recorded the last one and posted it. It'll be here on the wiki. I'll probably just delete this tutorial thinking there's nothing there, and I'll put it here on the homepage of the Pybase wiki as and again, it's not a whole channel of videos. It's just I do this video every so often and share it with people. So I'll put it here.
Sounds good.
Yeah, and if I ever, and when I do this again in another 6 months, a year, whatever, I'll keep the wiki updated with the most great, latest and greatest. So here on contributing, there it is. Last time I did the video tutorial was, well, it's been edited recently, but I guess it's been a little bit here. So I don't know. One of these updates, maybe that was February the 3rd. In any case, I make that more obvious, put it on the homepage. I think makes more sense. All right. Good deal. Any other questions?
No, nothing that immediately comes to mind.
All right. So that was a very simple, very straightforward contribution. A lot of I don't know if it's a mistake, but a thing that kind of discourages new contributors is that they try to start by making a huge swing and make a big contribution. Um, a very common thing is people like, ooh, there's a property that I care a lot about that needs to be added to the Pybase. And then they'll go through and they'll make a pull request that adds this property and maybe three other related properties as definitions to the Pybase. Um, and that's not typically going to be merged in directly because just because you can define it doesn't mean it's necessarily ready to be in the Pybase because we want to we have some standards. It's not we're not our goal is not to reflect all possible knowledge of topology. Our goal is to reflect what researchers and students of topology think is important. Um, so if I go back to the wiki and I go to the reviewing tab, that's kind of a good, so some of this is just mechanics of pushing the buttons that I kind of just showed a little bit of what happens on the back end. But also there's a reviewing checklist. All right. So first of all, we're going to thank you, if you make a contribution. We do appreciate it. But we do have some requirements for a new property. All right. If you want to add a new property, it should be of interest to researchers. If it depends on other properties, and generally it should, we should cite them in the description. And then we should add traits or theorems that allows us to tell the difference between that new property and other properties. Um, so I think in a recent example, I think it has been merged in, so I can show you. First of all, let me go back and reset this to the current state. So if you go to the advanced or the name of the branch that you're on, you can just hit reset and it goes back to the most recent version of the main branch. And A lot of the deduction actually happens in the web browser. So that takes a couple of beats, especially as we get more and more of our theorems in there. So now I'm going to go back, and I believe it was Archangelski's Alpha 1 convergence principle. Oh, we did actually add all of them. So, right. So we have all these different Alpha 1, Alpha 1 and a half, Alpha 2, Alpha 3, Alpha 4. And ideally, I'd love to have Alpha 4 imply something, right? So that is, in fact, we probably don't have any spaces. Oh, we do have example spaces that are Alpha 4 because any first countable space is Alpha 1, then so on and so forth down the chain. But we have no spaces that aren't Alpha 4 because we don't have Alpha 4 implies something that could be negated, and we have not manually put in any examples of spaces which are not Alpha 4. So this is not as complete a contribution as we typically have, but these are very important, very well studied properties. So I think that's why we decided we had an editorial decision that we would go ahead and include them. Um, right, but let's just look at Alpha 1. In this case, we do have examples of spaces that are Alpha 1, none that aren't. Again, we need to have something that Alpha 1 implies that could be false in order to automatically deduce things are not Alpha 1. Um, Generally speaking, if you're making a new property, I love to see, okay, what's a sufficient property that we already know about that implies it? What's a necessary property that it implies? And then if we know stuff, spaces that have those two properties on either side, then we'll automatically deduce things that are both true and false. We didn't do that for this one. Again, if it's hard to do that, then maybe and the property is important enough, maybe we'll get it accepted anyway. Um, and then, of course, if it's going to be different than those other properties, let me think of, okay, so here's a very simple example from K1 Hausdorff. K1 Hausdorff is a property that's implied by the Hausdorff, actually, semi-Hausdorff is even better. Semi-Hausdorff. Semi-Hausdorff is a property that's implied by T2 and it implies T1. And now we actually know spaces that are semi-Hausdorff and not semi-Hausdorff. And most of these are deduced because most spaces that are semi-Hausdorff are also Hausdorff. Spaces that are not semi-Hausdorff are mostly not T1. And we have a handful of examples that are asserted. These are all going to be spaces that are not Hausdorff. Oh, excuse me. These are all spaces that are T1, but they are not Hausdorff. So they had to be manually asserted that they have this property here. I'm a little surprised that we have examples that are no examples that are semi-Hausdorff. I could look that up, right? I'm curious. So semi-Hausdorff, but not Hausdorff. We must have examples of this. Aha. And so the 1 point compactification of a sequential fan is semi-Hausdorff, and that was deduced because we have some other properties like semi-regular and totally disconnected. But deduce that for us automatically because we do have some more theorems about semi-Hausdorff that we could use to deduce that we are semi-Hausdorff. So that explains that. All right. Um, so that's kind of to know that if semi-Hausdorff was a new contribution today, we would love to see that it is between T2 and T1. We would love to see that there are semi-Hausdorff spaces that are not T2. We would love to see that there are T1 spaces that are not semi-Hausdorff, whether that's established through adding traits or by adding another other theorems about semi-Hausdorffness. Maybe we already knew about semi-regular, for instance, that we could add T1 semi-regular implies semi-Hausdorff. That would all be enough to trigger the deduction engine and get us all the kinds of examples of that things that are and aren't semi-Hausdorff. We can go back to this wiki here, if I can find the right tab. Um, New space. We're not interested in tracking every single topological space. Generally, it needs to be either, well, if it's a really important example and to researchers, it's probably also going to satisfy that it is an example, counterexample to something that's not currently represented in PyBase. We study new topological spaces because they have properties that no other space witnesses. So generally speaking, if you have a search on the Pybase, um, for example, I want a semi-Hausdorff and locally Hausdorff space that's not K1 Hausdorff. I'm guessing this is strong enough. Nope. Okay, that's not. Uh, maybe maybe do the other way. Perfect. All right, we do not currently know of a semi-Hausdorff and K1 Hausdorff space that's not locally Hausdorff. There are two ways to close this search. You can give me an example of a space that has the semi-Hausdorff and K1 Hausdorff space, but not locally Hausdorff property. Or you could give me a theorem that proves that every K1 Hausdorff semi-Hausdorff space is locally Hausdorff. I don't think that's true. If I had to guess, there's an example that does this. But we don't currently know. And so that's basically the two kinds of scenarios we like to see. A new space that has these three properties that we don't currently have. It'd be even better if we had a space that we just didn't know whether it was locally Hausdorff. Maybe we don't know it's even K1 Hausdorff. This question mark search may not be, yeah, it's not working right now. That explains that. But in any case, it'd be great to have a current example that we could just add the extra property that we need to get this example. Or if we have a new space from scratch that would answer this question, that would be great as well. But if it turns out that every semi-Hausdorff and K1 Hausdorff space is locally Hausdorff, we would want that theorem. And then that theorem, whenever you have something like, if I want an example of a compact Hausdorff space that's not normal, it's going to yell at me because that's impossible because our theorems know it's impossible. And so it won't ask me to contribute an example of that type because we just know it doesn't happen. And that's kind of the rule of thumb for is your space or is your theorem important enough to be added to the Pybase at this time. Um, and so again, like everything else, if you're curious of where the community is at, this is a little bit stale. We haven't updated this in almost a year, but we do update it every so often in terms of our standards for reviewing. Um, Conventions and style are on this wiki as well. We have some of this is like mathematical conventions. For example, RT3 is both regular and T0, not just the regular property as some authors have it. So this is a great thing to kind of review and click through. It's great to also, before you do a lot of work to make a contribution, making an issue is a great way to get started as well. If I want to add a new space, before I add it, I could actually just make an issue to propose that new space through the issues. And you can just fill out this little template that kind of justifies what's been done. This is also the method you would use if you were not going to actually directly contribute to the Pybase. You want someone else to do the work for you. You would use this same form. But if you think there's some discussion or it's your first time making the contribution, you're just not quite sure, is this really going to be accepted by the editors? This is a great place to start as well. Um, all right, that's been about an hour. I think that's probably more or less what I had planned to talk about for today. Um, Pedro, do you have any questions that you think would be good to add to this recording for the broader community?
Nothing that immediately comes to mind. I especially enjoy the kind of um, requirements that if you want to propose a new property or space or theorem. And I also like that there's a template here if you want to add a new issue. But no, not immediately. I don't have a question.
Yeah. Well, that's good. Good. Hopefully I did my job then. Um, there is I think yeah, I'll just go leave it at that then. All right. Well, thank y'all for watching this recording. I'm gonna go ahead and stop the recording and then Pedro, if you have any other questions, you can hang on and ask that. But hopefully this has been helpful. The final thing I'll just kind of pitch to everybody is we love to have folks involved in the community. You can go to the issues of the Pybase. We don't use the discussion forum quite so much, but the other way to connect with us is through Code for Math. Code for Math is a AIM research community dedicated to the advancement of mathematical research. And in particular, there is a Zulip chat room, which is kind of like a Slack or a Discord, but it's open source. And we have a Pybase channel within that Zulip. So that's another place to connect with not just this project, but other mathematical research infrastructure projects, other databases, other programming languages, formalized proofs, and all that fun business. So hope to have you involved if you're watching this video. And I'll go ahead and call it there. Thanks for hanging out with us.